One common use of binding is to display data in lists, for example, a combo box or a list box. Whether you're retrieving that data from a database or using a collection in memory, it's useful to be able to display the data without having to loop through it one item at a time. Imagine this scenario. You want to display a list box containing numbers and also display a bar with the magnitude of that number in the list box. That is, something that looks like this. Well, you can certainly do this very easily using the tools you've seen so far, plus a little bit more. Let's start by looking at the base example. That is, how to bind a list of numbers without worrying about the bar yet. In our sample project, I'll select Data Template 1, and you can see a list box filled with the numbers between 1 and 100 in somewhat random order. Well, how is that happening? Let's look at the markup. In the markup, we have a list box, demo list box, and it has as its item source a binding using the element name Data Template 1, and the path is numbers. Well, what is Data Template 1? That is this user control. I've added a name attribute for this user control, something I haven't done before, because I want to refer to this user control in the markup. I have to have a name in that case. Here's the name, and the path is numbers. As far as I know, a user control doesn't have a numbers property. This one does. If I look at the code, you'll see in here a public IEnumerable event named numbers with a getter and a setter. So this public property I'm using as the source for that list box. You can see up here in the constructor for this user control, I create a random number handler and make numbers equal to enumerable.range starting at 1, take 100 numbers, and take the result of that range of numbers and order by the next random number. Basically, that ends up shuffling the numbers between 1 and 100 into random order. We do that in the constructor, so this numbers collection is available to us to bind as the source for that list. Given a list box displaying numbers, our next step is to modify the layout for each item in the list. The XML data template was designed just for this purpose. It allows you to pass one row of data at a time through some custom formatting as the control renders its output. The data template is simply a chunk of XAML markup which represents a single item. It defines how each row in the list should be displayed. The data template can contain any markup that you like, more than one control. It can contain pretty much anything. It needs to include at least one binding markup extension, or at least one binding anyway. Otherwise, it's pretty dull. Otherwise, it's the same for every row. Without some binding, it will be the same each time. Here's my tip. Start with static data, then add the binding. That is, get the template to look the way you want it to look, and then add the binding to make it different for each row of data. Let's look at a version of our list box that isn't bound, but gets items to look the way we want them. That is, it's the next step in the developing process. To mock up what I wanted the output to look like, I started by creating a layout much like the one you just saw. This time, however, I made a list box with items that I defined manually. So here I have the list box with a list box item defined. And inside the list box item, I have a stack panel with its orientation set to horizontal, a text block with the text 10 and the width of 30. That's this thing right here. Then a rectangle with width of 10, fill being red, and margin 0 on the left and right, 2 on the top and bottom. Then I have another list box item with a stack panel inside of it with the orientation set to horizontal, the text block with text equals 20, width equals 30, a rectangle with width equals 20, fill being red, margin 0.2. So you get my point. I'm laying out each item individually to get an idea for what I want in my data template. The results I want to end up with look like this. I'd like to have each item, in turn, displaying a number, then a rectangle displaying the width corresponding to that number. We've seen how to do it for fixed values. How do we do it then for the list? That's described here. In my list box now, I don't have fixed list box items. Instead, I have the item source, which you saw before. Nothing different here, except the element name is now data template 2 rather than data template 1, which it was before. But otherwise, it's pretty much the same in terms of the binding. How about the layout? You can see we've added a new attribute here, which is the item template. The item template is a static resource named number template. Let's come find that resource. Here it is, usercontrol.resources. Data template is a new element we haven't seen before. A data template allows us to create a block of XAML which is bound to some expression. Now here, I've given it a name, a key value, of number template, and that's how I refer to it here in my markup. But what's in that data template? Look at this. It's a stack panel with orientation horizontal, a text block whose text is something, whose width is 30, a rectangle whose width is something, and fill red margin 0,2. So this looks exactly the same as what you saw in this page. I just copied and pasted one of these, once I had it all laid out, into this page in the data template and replaced the fixed values with this binding element. In a data template, if you're going to bind to the item that's being displayed in the list, all you have to do is use the keyword binding in curly braces. That markup extension knows then to use the current element's value as the source of the binding. What could be easier than that? So this is all it takes to create a data template. Let's review the steps. You have to create the resource within the resources somewhere, either in the user control or higher up the tree. You create a data template element and give it a key. You refer to that data template by its key in the item template attribute of whatever item you want to hook this to. And then within the data template, lay out whatever controls you want to use with binding as an expression for the properties you want to bind it to. Here I'm binding to the text property of the text block and the width property of the rectangle. And we end up with exactly what I was looking for in this demonstration. Let's look at another example using a data template. You need to look for cases in your pages where you have repetitive layout information. I'm going to pick an example you may have seen already, which allows you to select an instructor from our courseware. In a previous example where you had seen this, you wouldn't have seen either data binding or a data template. But we'd like to replace what you saw previously with a data template. Of course, this technology isn't just limited to rectangles and text boxes as you've seen already. We can use it with any kind of control in the data template. Let's look at this example, starting with the bad scenario, that is, without templates and without binding. To review, I've loaded a sample page you may have seen in another part of this course. Here we have a list box which displays information about instructors or experts from our courseware. You can see there's a text block at the top asking who is your favorite expert, and down here we have a list box. And in the list box we have a stack panel and an image and a text block, and then another stack panel and an image and a text block, and another stack panel and an image and a text block, and so on for all the different AppDev experts. Clearly, the worst possible scenario. But here's the real problem. When I run this thing, I want to be able to display the expert that you've selected. Well, what's the problem? The problem here is in the source code, I have to be able to extract information from this tag property given the item that you've selected. The code gets kind of ugly. Let's look at that code to see what's involved to be able to retrieve the tag property from the selected item. In the selection changed event for that list box, we need some way to retrieve the name of the selected instructor. The problem is there's no easy way to do it. The selected value is a stack panel in that list box, so I need to take the selected value property of the list box and cast it as a stack panel. That's our stack panel, but now we need to get at the text block that lives inside that stack panel. We could loop through all the children looking for it, or we could ask for the children of the stack panel, restricting it to only those of type text block here. Once we get that collection, we'll ask for the first or default element of the collection, because we know there's only one, and we want the first one there is, and we store that away into this variable. Now, of course, whenever you call first or default, you should check to see that the return value is or is not null. We needn't worry about that here because I know that there is a text block inside each row of the list box. Given that text block, I use the tag property to retrieve the name of the selected instructor. It wasn't that hard, but it certainly was harder than I would have expected to retrieve that information from the list box. We didn't use a data template. We didn't use binding. The right way to do this, I think, is to keep track of authors in some sort of collection. Now, this could be coming from a database, but for this demonstration, I don't want to go to the database. I'd like to manage it in memory. So here, I have an AppDev author class, which has a name, a description, and an image path property. There's a constructor, which allows you to pass in those three properties, and will store them away into those public properties. So AppDev author is a very simple class with three string properties. And here we have a collection class named AppDev authors, which is an observable collection of AppDev author. Observable collection is a class which is useful for allowing you to, in XAML, bind to the collection. It has special features that make it very useful. For example, it raises events when its contents are changed. We're not going to need that, but it also allows for instant notification of changes in the user interface. Again, not something we care about. You can see we're going to add to the internal collection a new AppDev author instance for each different AppDev author. We have a name, a description, and a path to that author's image in our images folder in this project. Given all that, we should be able to lay out this markup. If you'll believe that that all works, let me go to the next version of our page, and you'll see in the code for the page that we have a public AppDev authors object named authors. Just like I bound to that numbers collection in a previous example, here I'm going to bind to this authors collection. Your brain should be ticking away saying, oh, he's going to bind the list box to that authors collection and use a data template to lay things out. It's going to look exactly the same. Visually, it will look exactly the same as the previous example. In the constructor for this class, we'll create an instance of AppDev authors and assign it into this public property. Now, when you select someone from the list, it's very simple, because the selected value in our list box is an AppDev author. We store that away into a variable named expert, and when we want to display the name, all we have to do is retrieve the name property of that expert. Way easier now. Now, there's a part of me that looks at this and says, do I really have to write this code to retrieve this name? I don't like writing event handlers. I'd much rather do all my binding declaratively. So I could, rather than placing the name property of the selected expert into the text property of the demo text block, I should be able to write a converter. So I could do this all using declarative data binding and not a single event handler. So here, I've created authorConverter.cs, and this is another converter class that implements iValueConverter. And in this case, in the convert back, Again, I'm going to throw a new not implemented exception because there's no reason or possible way to convert from this string back to an author. We have no reason to put it back into the author instance. We do have a convert method, and this convert method allows me to create a string that is the return value. I'll assume it's null. If the current value isn't null, which means we're being called at runtime after someone selected an author, we take the value, which is the selected value in our list box, cast it as an AppDev author, and store it away. And the return value is uSelectedAuthor.name. I'm sure you can do this with a string format property, but I wanted to show another example using a converter that implements the iValue converter interface. I've loaded Data Template 3 in the designer here so you can see the version that binds to the list we created of AppDev authors. Now you can see, first of all, down here when we describe the list box, we have an item source set to Data Template 3, that's this class, and authors is the property. And you saw that we had a property named authors which exposed a collection of AppDev authors. So that should make sense given that numbers example you already saw. We have an item template up here in the static resource area. We have an item template in the resources for this user control named author template, which defines the layout for this page. And we also have a selection changed event handler, which you just saw, which displays the name of the selected AppDev expert. Let's go look at the data template. Here I just copied and pasted the code from the previous demonstration, except I replaced the image source, the tag source, and the text source with binding expressions. Now remember in the last example with the numbers, I just had binding in curly braces and that's all? Well, that worked because I was binding to a single value. Here I'm binding to an instance of the AppDev author class, so I have to retrieve the correct property of that object in each case. In this case, we don't specify the element name because it is the element that we're bound to. But we do have to indicate the path, the property of that element that we'd like to display within our output. The image uses the image path, the path for the image. The text block uses as its tag property the name of the author, though we're not using that anymore. That's just vestigial. And here for the text, we use the description of the author. We could have removed that tag. We're not using it for anything. Okay, well, let's try it out. Here's our sample on that page, and you can see we do have the image and we have our description in a stack panel for each AppDev expert in our original list. If I select one, you see down here you selected Robert Greene, or you selected Doug Ware, or any of these instructors. And that works just fine. But I mentioned that it bothered me that I had to use the selection changed event to push the value down into this text block. The next version, Data Template 4, is exactly the same except it doesn't have an event handler. This time, the text block down at the bottom, here we are, has its text with a binding expression. Its element name is experts list box, uses this. The selected value is the path, and then we use a converter, author converter, to convert from the author into a string, which is you selected Robert Greene or whatever. If we come back up here, we can find that resource. There it is, local:author converter. That is the class name, and here's the key we'll use to refer to it so we can create an instance of that class with that name. And if we look at that example, it looks exactly the same. The only difference is we're not using an event handler to push this data down here. We've bound the text of this text box directly to the selected value of the list box with a converter in the middle that converts from the AppDev author that's selected into this string. It creates a formatted string for us. Just to cement the concept, I have one final example that uses binding and data templates. This is a question that actually came up from a user asking me a question, asked how do I display a list of color names and color swatches in a list box. In this case, I'd like to select a color from the list box and set the background color for a border control to display the selected color. There's a number of different ways you can do this, but I wanted to do it using the least amount of code possible. Let's look at the example and then examine how it works. To create this color list box, we start by creating the list box and binding it to a data structure that contains a list of all of the named colors available to us. Here's the list box as it starts out. The next step is to modify the list box, actually the border control that contains it, to bind the background of this border control to the selected color. So whenever I select a color, that becomes the color of the border control that contains the list box. The final step is to hook up a template so that for each color you see the color swatch and the name of the color, and still, if I select one, that becomes the background color of the border. So I think, or I hope, you follow the logic of this demonstration. Let's go back and look at the first one to see how this is working. We have a list box with its item source set so that we have a binding expression where the element name is color list box, and that's the name we've assigned to this user control, and the path is colors. So this user control exposes a property named colors, a public property, that is a collection of colors that we can use in the list box. Let's look at the code to see how that's working. In the example you just saw, the list box was bound to an instance of the ColorList class, and here is the ColorList class, which inherits from observable collection of string. You can see in this class a public enum named colorNames, which has one item in the enumeration for each named color available to you. I spent hours and hours typing these in. What I actually did was search on the web and found the list for myself. And down here in the constructor for this class, we call getEnumValues. It's this method here, which you can investigate if you care to. Has nothing to do with anything we're doing here, except it does take an enumeration and give me back a list that I can use to add items to my internal collection. So, given that enumeration colorNames, I get the results and I loop through each color in results and add each color converted to a string into the internal collection. So I end up with, once I construct an instance of this class, a collection of strings, one item per color. Seems like a little bit of overkill. I probably could have done it an easier way, but given the fact that this class exists, I now have an observable collection containing a list of all the color names. Just go with it here. Now, in our user control, and each example has this exact same code, there's a public property named colors of type colorList, and we instantiate that from within the constructor for this user control. So we end up with a public property exposing a list of strings that represent all the colors, and we bound that to the list box. So the first part of the problem is solved. Now how do we set up the binding for everything else? Just to review, our first example had a binding for the list box but nothing else. The item source property was bound to an element named colorListBox, that's this user control, and the path was the colors property of that list box. Now if you remember, we ended up with this layout, individual items in the list box, which are just strings representing color names. The next step is to do a little more binding. In this case, not only do we bind the item source property of the list box, we bind the background property of the border control that contains the list box. In this case, we bind demo list box selected value to the background property. I was very surprised when this worked. I had actually written a converter for this and didn't need it. The converter converted from a string representing a color name to an actual solid color brush, figuring I needed that. Turns out I tried without it. It worked fine. So that means somewhere inside the .NET Framework, somewhere there is a converter which converts from string, color name that is, into solid color brush when it's necessary. Because here, this property is expecting a solid color brush, but we're getting a string. It works. I created the converter and sort of tossed it away. As you saw this example, I select a color, and it does set the background color of the corresponding border control correctly. And again, we have very little code in this example. The only code we have sets up the colors property of this user control. Okay, there's the code that creates the color list, but you have to have that no matter what. Our final version of this has a little more effort involved. This is the one that displays the list of colors with a color swatch. To make that happen, I used a data template. I have a data template element named color item template in my resources, and it contains a stack panel, orientation is horizontal, with a rectangle and a text block. The rectangle has a fill property set to just binding. Remember, since we're binding here to a string, we don't need to worry about the path because there is no path. It's just we're binding to the string. The fill property again expects a brush, and somewhere some converter converted the string into a brush for us. Down here, we're binding the text to that current element. So we use the binding object name in curly braces to provide the binding for the text property. Otherwise, the markup is exactly the same as the previous example, except for this last attribute. We need to specify the item template for the list box. It's a static resource named color item template. Here it is in the resources, color item template, and that becomes the template for each item in this list box. I was astonished at how easy it was to create this list box of colors once I had created the collection class that exposed the color names. The binding was simple, the data template was simple. You'll see how easy it is to create full-featured lists using binding and data templates, as you've seen in these examples.